I've already seen how to work out the solutions of quadratic equations. Let's have a look at equations of higher degree. What do we mean by higher degree? In the case of quadratic equations, the degree is 2. In the case of cubic equations, the degree of the equation is 3 because we are looking for the term with the highest power. That's going to determine the degree. And in a cubic equation, the term with the highest power is the cubic expression x cubed or y cubed, whatever the unknown is. Now, the equations with degree 4 are called quartic equations. With degree 5, they're called quintic equations. Then we have the sextic, the heptic, and the octic equations. And we can go even further. So the power can be even higher. Now, in the case of quadratic equations, we had the quadratic formula that would always work and that would always help us in finding out the solutions. Now, the huge effort was made to find a general formula for the solution of higher degree equations, but with little success. A formula for cubic equations was introduced by the Italian mathematician Cardano in 1545. But this is on the set of complex numbers. We do not always have real solutions. Therefore, this topic is not going to be covered in high school. Now then, a Norwegian mathematician, Abel, provided a proof that there is no general formula for quintic and equations of any higher degree. So as you can see, for equations with a degree greater than 4, there is no formula and it's been proved. For equations with degree 4, there exists a formula that consists of certain parts, but that's very complicated, so that again is not going to be covered in high school. But let's have a look at some higher degree equations that can be solved without a given formula. You could see that in the case of quadratic equations, there were several methods, not only the formula itself, so we could factorize, we could complete the square, etc., etc. So we could approach the task in many different ways, not only with the quadratic formula. So why not having some methods for higher degree equations, or for some particular higher degree equations as well? If you have a look at these 3 examples, what is common in them? If you have a look at the terms with the unknown, and you have a look at the powers, what can you notice? And that's what we are going to see later on solving these equations. And that's what we are going to use in some ways. Now, what is the connection between x to the power of 4 and x to the power of 2? Now, the first one is the second power of the second one. Now, this is very, very lucky, because then we can simplify our problem. If you have a look at the second line, you can see that this is a quadratic equation by side. If we replaced x squared by something, it is even more visible. So let's introduce a new variable and simplify our work first of all. So instead of x squared, let's put y in the equation. Now here you can clearly see that this is a quadratic equation that can be easily solved using the quadratic formula. The 2 solutions are 9 and 4. But are these the solutions of the original equation? No. We are looking for the values of x and not for y. Y was introduced just to help our work, just to reduce the problem to a quadratic equation and make our life easier. So at this stage, you're not allowed to stop. Y equals 9 or y equals 4. But what is y really? Y is x squared. So now let's put x squared in the place of y. It helped us to find the solutions to some extent, but now we would like to work out x. So we return to x squared and work out the solutions from these stages. Please remember, if you take the square root of the two sides, we're going to gain two solutions. There are two numbers, the square of which is 9, and there are two numbers, the square of which is 4. So please, when you take the square root, make sure you get them both. So from both directions, both cases, we gain two solutions. From the first one, you get plus and minus 3. From the second, you get plus and minus 2. So there are 4 solutions, and substituting these back in the original equation, they're going to satisfy the equation. Let's have a look at our second example. Now here again you can see the connection between x to the power of 6 and x to the power of 3. The first one is the second power of the second. So we can again simplify our work and reduce this equation to a quadratic. You introduce a new variable, now this is y in my case, and you'll see the quadratic equation that can be easily solved again with the help of the quadratic formula. But be careful, because the solutions you gain will be the values of y and not x. So we still need to carry on. There are 2 directions to go. The first one is when y is 27, and the second one is when y is minus 1 over 8. They are indeed the values for x cubed. So then you need to take the cube root of the two sides. And remember, if we take an odd root, then we gain just one solution from each case. So from the first case you get 3, and from the second you get minus a half if you take the cube root. So you have to give the answer that there are 2 solutions. One of them is 3 and the other one is minus 1 over 2. And if you substitute this back in the equation and check your work, you will find out that they satisfy the equation. Now let's have a look at the last example. Again, we can apply the same method. You can see that the first term is the second power of the second. So you can reduce it again to a quadratic equation to make your life easier. You work out y first of all. From the 2 solutions you get for y will be 16 and 1. And then you return to x to the power of 4, because y is actually x to the power of 4. So x to the power of is either 16 or 1. Taking the 4th root of which you get either that the absolute value of x is 2 or the absolute value of x is 1. Again, please do remember that if we take an even power, the even root of the 2 sides, then you will get 2 solutions, a positive and a negative one. So from the first case you get plus and minus 2, from the second you get plus and minus 1. So we will have 4 solutions. Now these kinds of equations where the equation itself could be reduced to a quadratic one, where we could apply the quadratic formula, are called biquadratic equations. This is a specific situation, and this doesn't always apply. In any other cases, you have to try and find your own method, such as factorization, completing the square, or anything you have learned, and try to find the solutions that way. There is no given recipe, and there is no formula for any other higher degree equations where the degree is greater than 4.